You are listening to Within Tolerance, a podcast for machinists by a machinist. I'm your host, Dylan Jackson at Proteum Machining, and this week I am joined by Kyle Brunner. Welcome, Kyle.
Thanks, Dylan. How are you doing?
I'm doing great. How about you?
Good. Wonderful snowy morning here in Wisconsin.
Well, so for those who might not know who you are or what you do, big picture, who are you? What do you do? Where do you work? All that good stuff.
Yeah. So Kyle Brunner, I'm a senior applications engineer for Hermle USA. The North American headquarters are based in Franklin, Wisconsin, just outside of Milwaukee, Wisconsin. So I'm lucky enough to have them in my backyard here. And
very cool. Well, let's get into your backstory then. How did you become a senior apps engineer, and what story did you take into manufacturing?
Sure. So I guess my story kind of starts outside of typical metal manufacturing. I started working with my parents when I was in high school, and they owned a paper and plastic die cutting shop. So really we're taking flat pieces of paper and we're running them through dies. These are steel rule dies. We're smashing two platens together, very similar to a punching or stamping application. But, to be able to make a cereal box, you have sharp edges and you have dull edges at different heights. And we're talking the sharp edges are 0.937 inches high. The dull edges are 0.918 inches high. So when you bring these two platens together over a piece of cardboard, some of it cuts, some of it scores it. And now you have a nice line to fold your box on. And so we made a lot of different stuff that way. For me, that was my foray into playing with machines. And, we were working with World War era machines that were used to be maybe printing presses turned over to die cutters and stuff because they still had the main mechanics we needed of two platens coming together. But yeah, I got to really play with a lot of nice equipment there. Did that for a couple of years after high school. And then I got involved with a punch press shop. This punch press shop, I came in as a maintenance / setup guy. There we made a lot of, if you walk into a bathroom, you turn on your Delta faucet, you're going to see a hot and cold piece of aluminum in there. It looks like a little shell. We made those, right? Mass made, we come in sheets of aluminum and stuff. We spinning brushes on there, put the nice little detail you see. Some of them get screen printed over, some of them don't, stuff like that. So with that, that's where I started getting to play with dies and die sets. For the first little bit there, just moving die sets off the shelf and into the machine and back and forth. And I'll sometimes get a little slow on setups and you end up wandering into the tool room. So I was lucky enough to have two really well-experienced guys in the tool room there that didn't mind dopey old me coming in and asking a lot of questions. That's one thing I specialize at is I probably ask questions before I should, right? That was one of the things my dad always said, just maybe listen a little more. But going in there, and I my favorite part of this story that I always tell is the first time they actually gave me a hunk of stock and they wanted me to work with them, so they asked me to grab a hunk of bar stock off and go cut them a hunk of bar stock this long. Okay, awesome. Go over to the small horizontal bandsaw, set it all up, measure it out, cut it up. My tail is just wagging. I'm a happy guy bringing it up to the bench and the dude just laughs at me and chucks it in the bin. He's like, now go do that again. And I'm like, well, what do you mean? And he's like, do you know what draw is on the end of the bar? And I'm like, absolutely not. So he grabs the part and he shows me and explains exactly what's going on, and what the part he was trying to make out of it and stuff. So that's where I learned about bar draw. And okay, maybe I need to cut my bar draw off before I get into that. But, really those guys, they had some Bridgeport knee mills in there. We had some drill presses and radial arms. He did have a partially driven knee mill in there as well that he got to program on. I can't even remember which control was on there. It was so long ago. They had an old wire in there as well, and that was just a sprayer, not a submersible one. So that was just, why is there water everywhere in here? What is this doing? And I was already good at, doing CAD stuff and 2D stuff. I knew AutoCAD. I did all that in high school and kept that going through it even when I was working in die cutting. So when I was watching him draw on the screen and be able to make things, and hey, we're going to drop in this block and we're going to use this small wire and we're going to cut out something you won't even believe, and I see these punches coming out that we're doing it. I'm like, this is just amazing. Are you serious? Like I can't even cut a hunk of bar stock right. And this guy's just making jewelry over here on the EDM. So cool. I got really interested in that. So shortly after I stayed there for a little bit, but I had an opportunity come up at another company. There was a subsidiary of Caterpillar. So I got into a shop where we had 30 screw machines. And I was lucky enough to be the only person in my boss's 30 years of hiring. I was hired straight off the street with no screw machine experience into a setup position. Wow. They had a hierarchy of you had to be like a 7 years operator before you'd even be considered for setup. So I came in really upsetting the crowd right away. And, they brought me in and he was excited. And I got to learn again off of a couple just really wonderful guys that really knew their stuff on the screw machines. And I really did heed my dad's voice this time and really kept my mouth shut and my ears open and just sucked in everything I could off of these guys. So I actually came in to run their first CNC controlled screw machine. So they had a lot of Acmes and Wickmans in there. And this was a Wickman that had two gun drill slides that were controlled by a Siemens control on it. So we still had the cams, we still had all of that, but then we had the Siemens integrated on top of it. It was a pretty awesome machine. We did some really nice stuff. So we were making all the components for Caterpillar's hydraulic hoses. We're doing all the stems and all the shells that actually hold the hose onto the fitting. We were making all the fittings.
Wow.
So that was fun. I really enjoyed that. You go in there, it'd be the middle of winter, and you're working on machines that are cooking oil at 100, 120 degrees. You're wearing shorts and cutoffs all year round, and you're wet and oily, right? The first thing I learned, well, I shouldn't say the first thing I learned. One thing I did learn eventually off my mom was you come home and these oils are just soaked into your clothes. You really need to start mixing Coca-Cola and your laundry detergent, and that actually helps cut the oil. So your
Really?
clothes actually get somewhat clean. Yes. Otherwise, I still have stains in drawers from where those shirts and clothes would sit because it's gear oil, right? You just soaked in it nonstop. So
Oh yeah.
it was a different world.
Wow.
but that was a lot of fun working on the screw machines. I really enjoyed it. It turned out I got pretty decent at it as well. So I'd run the old ones, I'd run the new ones. We normally, as setup guys, you'd be kind of over 3-4 of them. But that's a different world because we got into wearing headsets and working with a second setup guy because there were jobs that even with two people, it was 16 to 18 hours, 16 to 20 hours of change over time because we have to change so much over on these mechanical machines. It's pretty interesting when you get down and you're, sticking an indicator on and you're cracking open a tool holder and tapping her a little bit with the wrench or a hammer, depending, just moving it 5, 10, 15 thou, whatever that final number may be. It's just a very rudimentary machine that was making very, very accurate parts at lot sizes and a rate that's just mind boggling, So it was, I really, really started to find a passion for it. 6 months into that job, I was the go-to guy on second shift along with one of our water spiders. So they had water spiders there. I never really got why they call them that, but I'm assuming they were just gods and just walked on water because you could bring any problem to them. They had the answer. They'd walk out. They'd show you how to do it. They normally took care of kitting most of our jobs and getting all the attachments together and stuff. And they were our gods out on the floor there. You needed something. They already ran that job. They've done it 100 times. They've set it up 100 times. They can walk you through any problems. So it was nice working with them and being able to learn a lot. 6 months after that, then they had a posting go up for a toolmaker apprenticeship inside the company. I went in for that one. That it was definitely something I wanted to get into because short of just having the screw machines, we had a secondary operation full of CNC machines. We had Nudie rotary transfer machines in there. We had a full assembly line. We did plating. We did mandrel bending. We did everything involved with making those hydraulic components and couplings. That there was a lot going on there. And the screw machine part, we were just kind of the grease balls of the shop. That was the dirty area most people didn't walk into.
Right, of
we
course.
Stay out of that room. There's oil dripping off the ceiling. Let's not go in there. But turns out I did end up winning that toolmaker apprenticeship bid. So I got to spend a few years there, working with, again, some great journeymen. We had one guy that stuck around actually a couple years longer. He was going to retire, but then decided to hold out. So I was lucky enough to work with him for a little bit too and really tap into 40, 50 plus years of machining that this, and he was one of your classics. I'm not going to say a thing. He doesn't say a thing. He was super quiet all the time. He'd come watch you. Sometimes you got to watch the nods. Sometimes all of a sudden he would just do something really small and I'd be like, wait, why'd you do that? And then I realized what he's doing. It's like, wait a second, go back over 20 minutes later, start asking him a bunch of questions. Maybe you get a smirk out of him, but I learned so much off of him. It was really nice being in there. So in there is where I got to start running Milltronics, little C mill there, with a partner control under a Centurion 6 control. It was the partner 20, or I think it was the 20. It was a partner machine with a Centurion 6 control on it, getting into that. So that was nice. We had some engine lays in there. So I've spun many, many handles for many, many hours. But we did have a Mazak QT10 in there as well because we made a lot of the recess tooling for the screw machines. So we'd start out with, the M42 tool steel, and we'd start going through and break this stuff down, get it roughed in, heat treated, gash it and all that stuff. And then eventually head on over and do all the finished grinding as well. So on top of being able to work off of these guys, making all of the fixturing for the CNC mandrel benders and any fixturing for the secondary and the CNC group there. Being able to go over and make my own tools. So I need a cutting tool, I need a reamer, I need a subland drill, I need a step drill. I can make all those now. And that was
How
a lot of
cool.
fun learning because I got to branch out. So instead of just working with, kind of my couple journeymen that were there, I got to reach into the other group of journeymen as well on the tool grinding side of the tool crib side of the shop. And that was fantastic because now as I get parts that come up and stuff, I have a better idea of, hey, we could just make a tool and this would be done. I don't have to worry about how I'm going to do this. It's pretty simple. Let's just do it and be done. So that was a lot of fun. The other thing we had in there too was Mitsubishi wire. So now I got to actually get in a little deeper with the wire. I had a really good wire guy there. So I still have my cheat sheet sitting in my toolbox back there, with my first couple codes on that first couple days I spent working with him. But those are the ones where you can walk up and all of a sudden I can be moving the machine around. I can do a quick cutoff program, these little things that I might need to do. And then again, as things start going on and you bring a part in, you're like, well, that's a pretty tight radius. How do I do that? Oh, wait a second. I know
I
how
got
to
a
run the
wire.
wire now. Yeah,
Yep.
throw it on the wire. So got to play with the wire on that. So, I mean, that was a lot of fun. Yeah, so I really enjoyed working there. I learned a lot. The screw machines were probably what really got me hooked the most. Being able to see 6 to 8 spindles, ripping material, watching all these things come slamming together, and then, controlled chaos, chips flying, oil everywhere, and then you hear the ka-tink, and there drops another part, and it all does it again just over and over and over. So it was really amazing watching 12-foot bars get thrown into this turret, and then watching these beautiful, shiny parts come out, passing CPKs, and just watching things run for hours and hours and hours, just repeatedly. It was very fascinating for me. So
That's awesome.
yeah, so that was that one. Then I moved a little bit farther down, back into Wisconsin a little bit. We were up north at that point. Moved down and I got to work for a small job shop. They had a couple verticals in there, some Daewoo 4020 DMV verticals in there. We also had some 9-axis Mazaks in there. We had some 2-axis Morris, a little bit of everything, right? We were gun drilling in there. So it was a nice all-around job shop. On the 4020s, we had 4th and 5th axis indexers on there as well, so we could do some more work. And I worked there for a bit. It was right before 2008, so it was an interesting time in the industry there. Second shift coming in, and that's where I really got into my FANUC side of things, because before it was the Centurion control, it's all conversational. The MITs, yep, okay, now I'm getting into some G code. All the tool grinding and surface grinding, that was all spinning handles, using the comparators and stuff. You're not reading any code whatsoever. It's all visual at that point. So, yeah, getting into the Daewoos and stuff and being able to play on those. I had 2 of them that I ran in my cell. And there were nights you didn't do any setups, and then there were nights you do 6 setups. And being able to kind of have that spread of work, you didn't know what was coming through. You did it. It was fun for me. Some of them were, oh, you need to write a program for this. And it might have been a simple facing or something at that point in time. Okay, cool. Let's work through that. And sometimes you're banging your head against the sheet metal, on some things. But it was, for me, it was great progression getting myself into, now I got a lot more fluid on what I could do with the machine and a lot more comfortable. And that thing would get jammed up and I could get into the maintenance side of things. And, I went in, I read the manuals. That was the big thing that most people don't do. And it's funny, it's a common thing you kind of hear in here is just reading manuals. Right, that's the manual. So I get bored at night, I read manuals. That's what I did on second shift.
Oh yeah.
So that machine go down. Hey, supervisor, this is what I'm going to do. I think this is right. He checks. Yeah, go for it, man. I think you're right. Cool. Go check it out. Try it. Sometimes you win, sometimes you fail. In the end, we never failed completely. You always came through, but maybe a couple battle scars with it or something. But
For sure. Yeah. No, I started in a job shop as well, so I it's not an easy job, but it is, like, I think one of the ways you can expand your skills so quickly, because like you said, you might do 6 setups in a day, or you might have to, fix a machine while running a machine while programming. It's like it's everything, all at once.
Yep. Yeah. Probably also the shop I mopped the coolant off the floor the most, just because of trying to, be all over the place and doing things. And I'm trying to, look good, and I'm trying to keep going, and, and yeah, all of a sudden you turn around, and oh man, forgot about that water running back there,
Yep. Oh yeah.
Yep. Get the mop back out while you're still trying to finish the setup and stuff. But yeah, that shop was a lot of fun. Unfortunately, in 2008, that company had to lay off second shift for a little bit and stuff. So I took a month or 2 off. I played with some hobbies and stuff and just took my time. And I'm like, at some point I gave them a call and I'm like, they're like, well, we got some back to first. I'm like, all right, well, I'm going to go find something else. If it, don't work out, I'd love to come back, yada, yada. But,
Right.
something is happening. Well, it didn't take me but a day. And there was a company in Milwaukee, Wisconsin here. They make their own machines that make paper cups and paper containers. So it's
going
Paper
full
Machinery
circle.
Corporation. Yeah. Right. So now I'm back into the paper world again. But very interesting. I came in there as a horizontal machine operator, setup guy. So running a Makino A71. It got to go through. I was working opposite of the first shift foreman. So again, for me now, I get to work with, another top-notch guy who is able to help lead me and guide me some things. And I'm probably going to be able to do a few more cooler things because I'm following the lead man, right? He's going to get the more special jobs normally during the day and stuff. So I was able to take that and run with it and really started having a blast out there. We had a lot of different machines. We had Kitamuras in there. We had Hitachi Sikis, Toyotas. We had pallet systems in there. We had another Mitz wire in there. All kinds of accumulators in there. And we started getting into grinders. So we had a Kellenberger grinder in there. So a really nice wide variety of machines, because really what we did is with making our own machines in-house, we made all the tooling in-house and kept that, quality control inside the building. Some other simpler items and higher quantity items, those actually went out the door. When I worked there, we were making quantities of 5 to 8, and that's kind of what you're going to make per lot.
Okay.
Turret's going to have 5 to 7 positions. There's normally a spare being thrown in there somewhere. So the biggest thing with that is the tooling stack up. So you start with a turret, and then you get this part of tooling and this part of tooling and this part of tooling. Well, as these stack up and the tolerancing, it changes a lot from position to position with all those multitudes of tolerances. So we really, most things said 5/10 tolerance. We really, once you got a job running, we did our dangest to keep that thing within 2/10. That way, when everything gets stacked up and all those tolerances add up, it's a much smaller delta from your high to low. Because as you start stacking up these finished cups, if you ever walk through the store, look at the cups stacked up on a stack. If you notice something would be off, it'd be like every 5th or every 7th cup, you would start to see that different gap all of a sudden.
Okay.
It's really minor. Most people won't notice it, but it is there. And that's something that, we truly took pride in, is that our customers could swap over tooling to go from container to container, and all their tolerances are going to be there. The parts are going to come out like they expect them to come out. It's not that this one needs to go back onto this turret position and this one needs to go over here. We kept everything tight enough that if you called and said, I need 1 replacement out of 5, we can send you 1 and it's going to fall into spec. So that was good there. My favorite part of working there was, at some point though, on second shift, you really kind of get left in the dark when there's no CAM programmers on site. So this is where I started my foray into CAM programming. I found out that the programmers obviously have dongles in the back of their computers. So they also have install CDs in their drawers usually. So I found an X3 Mastercam install CD. I brought in my laptop.
Okay.
I bought a used laptop just for work. I installed X3 and I'd steal their dongle when they left. So my nights
smart.
then, I spent my time training myself Mastercam.
That's awesome.
It was fun. There's nights I'm still running 2-3 machines, running the wire, helping out other guys, whatever. But then there's times I'm just going to go sit down. I've already gone through all the Fanuc manuals. I've gone through all the Makino manuals. I've gone through all the Kitamura manuals. I've gone through every manual I could pretty much get my hands on in my area. At this point, I already, took the probe out because we apparently had a MP700 probe sitting underneath our table that no one used for like
nobody
3
was
years.
using it. Oh
No.
man.
I pulled it out, put new batteries in, it worked, got through calibrating it, and all of a sudden, it's integral into the thing. So yeah, I wanted to get into some more CAM programming now. So I stole the dongle, started teaching myself programming. And it worked out because shortly after that, all of a sudden my boss put a posting up and they were looking for another CAM programmer. And obviously we did use Mastercam there. So when I came in and threw my name into the hat, he looked at me and he's like, but you don't know CAM programming. I just interviewed you, right? I didn't hire you that long ago. And I'm like, yeah, but I do now. And he's like, well, how? So I explained the situation to him and he's like, you got to be kidding me. And I'm like, no. So I went and I grabbed my laptop. I walked into the one guy and I'm like, hey, I need your dongle real quick. I pulled it out of his computer. I walked over, I plugged in, and then I showed my boss what I've been working on, right? I didn't have access to the company files and stuff like that because I wasn't on the network. So I just made my own stuff, drew it all in Mastercam, did everything in Mastercam just to start working on applying paths and everything else and just using the interface. So ultimately, I think that helped win me the bid. And I did get that programming job. So then I spent like the next 4 years as a daily programmer at that company. That was a lot of fun because then I really got to get involved with programming on all the machines. So I went out there. I spent my time on the floor with the guys because I was a floor guy. I worked with the CAM programmers before. CAM programmers don't like the machinists. The machinists
Right.
don't like the programmers, right?
Yep.
In certain in certain areas, right? We were a larger shop there, so there was a lot of machinists. There was only a few programmers. They don't like being inundated by everybody.
Right.
So I tried to change that mantra a little bit when I came in, and I spent some time out on the floor. These are guys that I worked with, right? They know that I've ran these jobs. My boss had me in the lathe department as well as the mill department. I knew the workflow. I knew the equipment. I knew the families that were coming through. So I really worked out there like, guys, what are your struggles? What makes this job not easy? Why can't you just come up, set up your tools, set your offset, and hit go? Tell me these things, and let's work through this. So for me, I wanted obviously to make a good impression, but I also wanted to learn. So I made sure I took that initiative and spent the time with the guys, and we put a lot of time into it. I actually just talked to a guy not too long ago, and they tell me when they still see my initials KRB up on the top of the setup sheet, they just hit go and run it because it's still a good program.
Oh man, I don't think there's a bigger like compliment you can get as a programmer and machinist.
Yeah, it felt pretty good because it was difficult, and I did run in that group, and not all jobs were programmed the same, and certain tools that they ran, they didn't get updated tool paths, so you'd always break them, so you knew you had to go in and edit the program, and just these little things. And it's like I made a sheet for it because we kept job folders and stuff, so I made a sheet, and I'm like, guys, here, let's try and figure out this little sheet template. Let's communicate back and forth. You don't like this job, throw it in the bin. Tell me it's junk. Tell me it's a pile of garbage. I don't care. Throw it in there. I'll get you what you want, as long as obviously we're all in agreement, right? Not everyone gets a say, I guess, but
Right.
rule by tribe here. And I said, all right, let's go, and we go through it all. And once we get a running job, they check, hey, it's perfect, awesome, thank you, and then we just log it away, and then we leave those notes in there. So they pull that folder out. They're like, man, I wonder how this job ran last time. Open it up. They see the sheet. Oh, it's their name, their date. Said this job ran awesome. I think they're going to be pretty comfortable in running that job.
Right.
So
Exactly.
it was little things like that, because all of a sudden, you go through and you spend your time fixing a job. And then because we had an in-house engineering group and we made our own products, this was a very huge problem for us. The revision changes were nonstop. And that's fine. And revisions need to happen. There's reasons for it. I don't question any of that. That's going to happen. And it would get down to us, and everything would happen, and Cam would redo it, and it would get out to the floor. Except the floor and Cam never communicated after that first go around on all the problems they had. So every single problem comes back again because, well, I just used the same file. Oh,
Right.
that file wasn't good in the beginning,
Yep.
So getting through that really helped me kind of cement my spot with the guys, that I could walk out, ask what was needed. They would actually give me honest responses. If they were being picky about something, that's fine. I'd be like, hey, if we could do this, that'd be fine. But bare minimum, this is what we want, because then our job is this simple and it just flows. And so we got to that level, and it was great because there was jobs you could see the programming time went down to nothing, the operation time went down to nothing, reworks went down to nothing, because everything was known. There was an expectation of, hey, this is how this job is supposed to run. This is the way we set this up. As long as it's going to run like that, we understand all the variables we're running through, and it should not be an issue. So that was a lot of fun for me there. I really got to stretch my programming knowledge. I really got big into macros there. I don't know how much you get into macros, but I got into the macros because we had so many different manufacturers of machines there. They use different M codes for a lot of different functions, different 0 points. So if we want to try and program center a pallet, you can't do it easily. So it just goes machine to machine to machine. So I kind of had, and now this is a FANUC, right? I don't have the wonderful Heidenhain tables and stuff like that. So I make my own table with a FANUC program that stores all these numbers and then writes them to the 900. So every machine I could queue and say, hey, basically give your machine DNA as we built it up. And then it spits me out all these numbers back. And then I can say, hey, go turn on the coolant. And it's actually this pound variable, not pound, not M7. It's pound 907, because maybe it's 51, maybe it's 7, maybe it's 12.
Oh, cool.
All the machines would use different ones. So then I didn't have to worry about that.
That's super smart. I like that a lot.
The biggest reason for it was because Makino uses different probing numbers than most other manufacturers, right? So most of them are going to be the 9800s when Renishaw gets put on your machine. Makino's already using the 9800s, so Makino actually gets flipped over to 9500 typically, and now you can't run the same programs on two machines.
Gotcha. So your G65 lines were just calling variables, not actual programs.
Yeah, and we used to make some parts that would come in as castings. We call them folding wings. So they're basically the components that would wrap the paper around a cylinder to form your cup or container. And there was only certain parts of this folding wings that we machined. Um, I ended up writing a program for this that we go and probe 26 different offsets, and we update this as needed. So sometimes we're maybe adjusting just Z so a countersink depth goes to the right depth. Sometimes we're adjusting Y because I'm adjusting to a rib height on an arm that's sticking out. Sometimes you're adjusting X and Y. It goes through all of these things and updates, and it does it automatically. It used to be something that guys would spend hours aligning these parts. We probe and it's up and running in 10 minutes now at this point.
How cool.
Yeah, that one was a lot of fun. It made it real easy. Now I see guys sitting down and being able to get their next job ready, anything else, cleaning their area, whatever it is, instead of spending all of their time manually moving around a beautiful brand new machine. So, but the hard part was, depending on the machine it got stuck on, the probing routines were different.
Right.
So with that, now I need that. The other ones, we had legacy jobs that were ran off of center of index off of a machine we didn't have anymore. Well, that doesn't really work out very well, and you have to modify things. Well, I wrote a different little macro for that one that actually takes all that into account and can move those points around in space and updates all that. So I found that I've learned a lot of, I won't say life lessons, but maybe manufacturing lessons working there. I found I don't like working hard. If I'm going to do something over and over and over and over, and I'm on a CNC machine, why is this not automated? Right? When we were doing math for center of index and where my rotations are and stuff, I'm like, because obviously, right, so many people don't buy certain FANUC options that would do this for you. Well, it costs too much money. And really it's $1,000 option, $1,200 option. This is nothing. Fine.
Right. Long term, it doesn't make any sense.
No, not at all. Just pay for it and be done, right? The scratch pads we had with trig going on, just to rotate our point around in space on a B-axis, was ridiculous. So I got sick of that. So I wrote a program that do it and just wrote it into every program. It does it on its own. You didn't have to do anything. You set one work offset, run the program. It'll set as many as it needs to. Doesn't even matter. It can be one, it can be a million, because it can overwrite as you go through. So it just does it, right? Another thing I learned there, I kind of have two rules. So as we get in and I keep going here, I've done a lot of trainings and stuff, operator training. But I learned really two solid rules that I kind of stick by. And, one of them is going to be assume nothing. If you question someone else, if you question yourself, if you question it, just stop and go double check it. Assuming is absolutely going to get you into trouble in manufacturing. Right? Yeah. It's not just that it's going to make an ass out of you and me and we're not on the same page. It's more like, well, I assumed you bolted that down, or I assumed you already put the tool offset in, or I assumed you had the work offset set up already because you were about to run it. No, none of that's true.
Yep.
And
100%.
The other one that kind of goes right in line with it is it's assume nothing, and the other one's trust no one. And then that again includes yourself, right? You second guess yourself. Stop. I just listened to the Mickey one, and you guys were talking about this, and it's so true. Like if you need to stop, you are going to be the one that causes most problems for yourself. So just if you have that inkling, that gut feeling, that question, it takes nothing to hit stop, go double check yourself, rewind, just whatever it is. Because if no, you know what, whatever, I'm going to let her go. I'm normally right on my first intuition. And then you're like, oh, yeah, I definitely should have stopped there and checked that one out. That cost me more time now than, would have if I would have just rewound back and took 3 steps back.
A broken tool or a crash is always going to cost you more time than just double checking yourself.
Absolutely. Absolutely. And I got burned, and I won't call it the fault of the guy I was working opposite with, but he was a very in-demand guy. So he would try to do something on the machine and get pulled away, right? He always getting pulled away. I'd come up, oh yeah, you're good. This is all bolted down. Everything, you're ready to rock. Walk up, touch the fixture. It slides off the table. Holy cow. There's not even a bolt near this fixture, man. What are you talking about? And there's just some things that it's like, okay, I'm going to slow down a little bit, take that extra step or two back, double check myself. And that's helped me a lot. There's a lot of things where you just, hey, you know what? Let me just recalculate this for a second. Let me double check my numbers. And maybe all you're doing is just giving yourself a little better gut feeling about things, and that's fine too, because you need to have that when you're running these jobs too. But yeah, there was 2 big sticking points there for me is what I got to learn, but it was a great place for me. I really love that place. I recommend it for anybody. It was a really nice shop. We had white epoxy floors. There was a mezzanine on top that the bosses like to walk customers through and stuff. So I can guarantee you could eat off the top of my machine. If you've ever seen any horizontal on top, there's no chance of that. You could eat off of ours because we were up there probably every 2 weeks, sometimes more, depending on your runtime and stuff. But the tops of the machine stayed clean because the floors were clean, and the mezzanine, people coming through, so it was good. There was a lot of floor cleaning there too, because white epoxy floor, that's
Oh
what you
yeah,
do. You keep it
shows
looking
dirt
clean.
real quick. Yeah.
Yep.
So then, what made you move on from there?
So from there, I saw an opportunity to go work for Ellison Technologies and be an applications engineer. And at that point, I was doing really good at paper, really loving it. But I was able to branch out a lot more. For me, when I get bored and things get monotonous, that's not my fire, right? I don't have a
Totally.
burning desire at that point then. And I like to keep learning new things. I have to learn new things, and that keeps me moving. So I saw the opportunity to, instead of working in one shop, work in a lot of shops. So I worked for Ellison for almost 10 years, and that is absolutely something I got to do. Came on when we had the DMG Mori brand, got to do a lot of, really good training with the DMG and Mori guys there, going down to Illinois. I think the second week I was on, they had their I days, and I had to go stand in front of a machine for a week and do their I days show. And yeah,
Oh wow.
that was my first play on, a brand new Mori horizontal at the time that they put me on that one. But then because I had previous experience running some multi-axis stuff, I got to play with the DMGs a lot, getting into all the DMUs, the DMCs, the small ones, the big ones, the horizontals, lasers. I got to play with everything, and that was a lot of fun. That was a lot different than what I was doing, and now I'm playing with brand new equipment pretty much all the time. You still go in and work on some older stuff, sure, absolutely, but turnkeys and stuff are typically going to be driven right off of brand new equipment. So that was fantastic. I'm playing with other people's machines, and I get to move around a lot. So for me, it was fantastic working there. I got to do a lot of different turnkeys. Obviously you're going to do your time studies and your sales support and stuff, but the turnkeys is one thing we really did and did well at. So got to work in a lot of different shops in Wisconsin, and then also throughout the country, as my time with Ellison was going on there. And, we lost the DMG Mori line, and then we took on the Doosan line. In certain areas, we also then eventually got the GF line. So we had George Fisher being the Micron Mills and the Agi Charme EDX.
I didn't realize that they had that.
In certain territories we did, yes. Midwest being one of them. That's in some of them. So with that, now I get back to my EDM experience again, which I spent a lot of time on EDM. So being able to run an EDM again, I got to go over to the factory in Switzerland, done a couple runoffs over there. I got some factory training over there. So that was fantastic. But on the mill side, that was, so now, up to my point in career, I've already been on the Siemens and the Fanuc quite a bit, Centurion 6 control in there too, and some MITS controls. But now with the GF stuff, I get into the Heidenhain a bit more. The DMG line, they're real heavy on Siemens, especially in our territory, very heavy on Siemens. We only had one machine that I was aware of that went out with the Heidenhain control.
Oh, wow.
So we didn't see that very often. With the GF, obviously, they were all 530 at the time, unless you got into their mill turn product. And then that's typically when builders go over to the Siemens control. But I went and spent a week down at Heidenhain and got trained down there on the control, which happened to be on a Hermle as well. And then the next week went down to Micron and worked with one of their apps guys, Peter, guy I like to still consider a friend at this point here. And me and him worked together on their machines, and I got to now take, my practice or my knowledge and put this into practice. So I crack open the computer, start programming some paths and stuff, and just throwing some stuff together, machining, getting these machines to dance, and learning what Micron does with the Heidenhain control and what they do and how those things lay out. So I had 2 weeks there where I got to just strictly play with the Heidenhain control.
That sounds like some fun.
It was a blast. I learned a ton. It was a breeze. It was, with the Siemens control, and I've done all the 5-axis and Siemens already, especially with the DMG stuff. A lot of it really, I could correlate to things very easily. But the Heidenhain control is very simple to learn. The week after I was done with those 2 weeks, I had to go work and do a training for a customer. And there I was back on the Zero Eye Fanuc control. And I'm like, oh man, this kind of hurts, nothing against Fanuc. It's paid my bills for a long time. And it is a great industrial control. That is what they say it is. And that's exactly what it is. It can be put in a lot of places. Absolutely. But after I just got done playing with a Heidenhain control on a very high end 5-axis machine, European built, it was a stark change the next week.
Oh yeah, so, I'm sure.
But that was the start of it, because then we were able to bring in a Micron on our floor, So then I actually was able to play with it a lot more. Really got into some things. We did a runoff with a customer over in Switzerland. I was able to use their runoff acceptance part for a demo that we were having in the showroom. I went, I reprogrammed it all in Mastercam. I actually ended up running that one through Complete as well at the time. And, I spit out really good code, and I'm like, sweet, I got it through the roughing, and I hit go, and I walked out the door and came in for the open house the next morning. The machine ran for 7 more hours after I left, and the part was done, and it was perfect. I'm like, all right, cool. I like this. I
Yeah,
like
that's
this
the
a lot.
dream. That's awesome.
Yeah. So that was a lot of fun. We get to play with a lot of different brands, and with that, we didn't have a lot of guys on the team nationwide within the group that knew the Heidenhain control. So I was called upon a few times to go to some different territories and help with the project, help with an engineer, whether it was taking the project over or helping the engineer get up to speed. They were calling me around that. So I didn't just stay exclusively in Wisconsin at the time. Then I started moving around a little bit more.
Okay. And then more recently is when you transitioned to Hermle?
Yeah. So I was really lucky to be gifted with such well built European equipment and the Heidenhain control. And, there came a point where the path I wanted to go involved just a little bit more technology. And Hermle, I was watching at the time, was looking for a position that I felt I could fill very well for them. I have, 3 kids at home. Travel was getting higher and higher for me, and that was getting more difficult and stuff. Just the kids are busy. It's unreal how busy kids' lives are with everything going on with school and after school sports and everything else. But with Hermle being in my backyard, it was something that fit the family a lot better. And, I was able to come in, and I tell everyone I come in and I work in the cleanest sandbox in the world right now. I'm just a kid who goes to daycare every day, and I play in the sandbox with my Tonka trucks and my diggers. And that's all I do. I fill bins with chips right now. There's a lot more to it than that, but at my core, that's how I feel, and I love it because we come in, and whether it's something that's coming through on the hotline, a customer's trying to do something and they're struggling, we're able to jump on, throw it on our machines right away, go test it out for them, bring it back to them, give them the yays and nays and pointers, get them on the phone, jump in, team view in. We can, from anywhere in the world, from my computer, I could team view into a customer, and then from their computer, VNC into the machine, and I can walk them right through. I can do everything except hit the NC start button. So that's pretty nice, and that's standard, So being able to diagnose and troubleshoot like that is something that's really nice on the controls. I recently just got back from Germany here, so I was able to go spend 2 weeks over in Gosheim. I got to see the factory. We did a wonderful factory tour. We even got to go in and to Rottweil and see the sheet metal and the casting division. So we've seen our castings being poured and sheet metal being pulled out of the racks and running through, hitting up the laser first before it goes to the bender. I mean, it's all automated and stuff. It's a very nice setup that they have there. So I've seen some factories before, and I was thoroughly impressed with what I saw with the Hermle group. Absolutely.
That's awesome.
Sounds like it was great. That was just the first day. Then the next day we were lucky enough to travel over to the southeast side of Germany, and we were spending basically like 2.5, 3 days at Heidenhain. So we got in and we started like Wednesday at noon till like Friday at noon, but we were able to do a TNC7 training with the training group from Germany there in Heidenhain, and then also get a nice tour of Heidenhain as well. That campus is huge.
Yeah,
it's unreal. I think their canteen is bigger than our building here in the States because they have so many people. It was like 4,000 people or something. It was just ridiculous numbers, but beautiful facility. You got to walk through, see the production, see them making the glass and everything and the scales and just everything they have going on. It was top notch. It was top notch. That was a really, really neat experience.
So, how cool. Well, actually, this might be a great time to bring up one of the questions from our listeners. LHM Engineering asked, TNC7 versus TNC 640. How's the learning curve coming from the 640? Anything that stands out on the new control?
So I have been around a few times, and I have been through a few control releases. A lot of the control releases I've been through have been, maybe not the control builder trying to do something, and there's always like a OEM builder overlay on things to try and make it more expansive than it is. TNC7 does a really good job of setting a new standard compared to the 530 and 640, but retaining everything that the 640 can do. So it is a different graphical layout, but now I'm free to set this up as I please based on users. I can drag screens around if I want to see my tool information, program information, subcalls, some different things. It's just a lot more flexible that way. But I think there's a lot less keystrokes to do things so far. And there's a lot more power in it because with the new NC software version, I think it even started at 11, but now 16 and 17 as well here. We can bring in holder STLs, we can bring in fixture STLs, and we can bring in finished part STLs to do a file compare. So you could bring in your finished part as an STL, run it through test run, and then do a file compare against the test run results versus the finished part STL. It'll merge in, give you those pseudo colors, and you can see where you have material gouge, material left, and whatnot. The nice part with this is anything you bring in as far as work holding and models and tool holders, it now uses for collision monitoring. So that's all built in right away. And then one thing that nobody saw at IMTS, but we got to see in Germany is on version 17, soon to be 18, I believe, but on version 17, there is a function now where we bring in an STL for our workpiece. And I set this in the space of my blank in space, basically, and set this in the machine window. I can touch on that STL and I can start tapping buttons around to drive this thing around, depending on where I truly put it on the table. And I can go move this and get it into a rough position. Then without having to do anything, I just call in my touch probe and I can start moving the machine around in any of the 5 axes. It does not matter. I don't need to turn any modes on. We're just going to get that probe in a position where I'm going to start touching off this STL. The control sees, it knows the tool length, it knows the probe, and it knows roughly where you put your STL. And now it tells you as you get the probe closer and the stylus closer to the part, hey, I'm going to probe to the left. And then you hit start and it goes and probes to the left and you jog around and you probe to the other side. And it starts using your probe beeps as constraints for placing the fixture where it's actually finding it in the machine. So when it's doing its collision monitoring, it is real. It's not that I was just at 000 because that's what I had in my cam world. Maybe my guy threw it on there half a degree off. This thing will pick that up and put all that information in there and do it for you. You don't have to go into your 3D rotation button. You don't have to enable or disable this. This is automatically a function when you say workpiece setup, click, this function is active. So first it's the work holding and then it's the workpiece. So you do the work holding first, beep, beep, beep. That's placed. You then say, here's my, whether it's an STL or just a straight block form, a square, whatever that piece is, you bring that model in there and then you do the same thing and you probe it. We took a pretty wild part that they had in their tech lab. It was a demo they used over in Europe a bunch of times. It had a round boss. It had an angled arm coming off of it, some ribs going in a bunch of different directions. And that was the model we brought in. So when we set our part up, we skewed it 20 degrees in the vise. And on the control, we kind of said, hey, we're skewed. It kind of looks like this-ish. I don't really know, but it's close, right? It kind of looks like that. You probe 3-4 points, and all of a sudden that model comes into the real world space of how it's sitting. All of a sudden you look at it and you're like, yeah, that's exactly like it looks on the table right now.
Oh, how cool.
And so that took care of setting my offsets, because when you bring that STL in, there's a 0 point. That 0 point is going to be my preset value. So as I'm going around freely probing this part, it set my preset for me. So I don't even have to do that now. Preset's already been set because I was already probing this thing. So it's using all the features it sees on the STL, and it's using the features that it's probing to set this place in space. And now everything's done. It was fantastic. It was phenomenal to see that and actually be able to use it, right? It wasn't something that was just thrown to us on PowerPoint. First we saw it on PowerPoint. Then we went through and did what we could on the simulators that we had in Heidenhain. And then we went and took a walk over to that building and went into basically their sandbox, their tech lab where all the guys play. All the future technology is going to come out of. And that's where we got to actually then all of us ran through, ripped the machine down, all of us set it up individually, went through the work of doing all this probe, and then ran the program, and it ran beautifully. No problems. You'd see collisions before they have all this stuff. It was fantastic.
That's really cool. Yeah.
TNC 7, it's going to be very good. I don't think it's going to be that much for most people to get used to. So.
Well, to step it back, or I guess to something more recent, MKE Machine wanted to talk about the gingerbread house you guys just released a video on, and you were part of the team that made that, right?
Yes, yes, absolutely.
So, what challenges did you face, and how the hell did you even approach programming something like that? Were his questions.
So first off, I'm going to say Dave Miller, CNC Software, head of the partners group there, did most of the work on that. He's been a treat to work with. I've known Dave for a lot of years, but he did most of the hair pulling out on this one. But this part was definitely a challenge. Obviously, the first thing, first and foremost, is it's going to be an STL. All right, so this is a mesh of however many triangles that was purchased, and then we go through and we then try and take a look at how good or not this model is and what can we clean up. Luckily, Mastercam actually does have a very nice suite in there. On the art side, we could do some stuff. On the mesh side, we can do a lot of things. And we were able to get this thing into something that was truly manufacturable. For the most part, right? In the sense that I can get tools in there and I'm not going to be trying to dig through the roof to get this feature, stuff like that, right? Making sure all the holes are closed. Then it really comes down to most systems are going to have very small toolbox of tools that can work with a mesh. So if you consider a flow line toolpath or you consider a bounding box guiding curve toolpath, it's using the outside extremities of a surface to dictate which way it's going to go, right? It's like using the outside, the shoulders of a road to say where the center line is going to be painted. When you have 50,000 roads all placed on top of each other that all go different directions and have no real normal, the toolpaths really like to spaz out and go nowhere, right? You're not going to get anything real out of it. So the biggest thing, and this is something that we did another video that we talk about, is there's a lot of reference geometry that's needed for this. Anybody who uses Mastercam and has seen some of their videos, there's one thing that they do really well is, keeping things simplistic and really like, let's just get down and do the cut pattern first and not care so much about collisions and some other things and tolerances and step overs and, all this, like little mundane things that really refine your toolpath. You need to have something first before you can even worry about refining it and adjusting it. So setting down, like when we did the one side of the roof, there's a flat surface underneath there, right? So we drew a lot of manual surfaces and a lot of manual solids as well, because different toolpaths react differently. With a surface, if I adjust something, that may or may not reflect back to what I was doing with a solid as I go and want to adjust a radius. It's very simple for me to click, do a push-pull on this radius, and then the toolpath automatically updates, versus having to go through and recreate 16 different surfaces and geos and sweeps and all this other stuff. So there was a lot of differences. There was a lot used between the surfaces and the solids for us to have reference material for our toolpaths. So the toolpath doesn't look at 20,000 triangles to try and figure out what it's going to do. It's going to look at one triangle being this flat surface, and it says, hey, I can make this beautiful raster toolpath go back and forth, right? I'm going to zigzag back and forth. It's beautiful. And then we start saying, hey, now comp forward or backwards to my actual surface of the STL. So their first path is going to be driving right on that flat surface, and it's going to basically collide with everything. But then you say, hey, comp back along the tool axis at this point, and let's get back to my surface that I actually want to put this tool tip onto. So that's how you get the roof and the icing that's on there and stuff, because otherwise it's too many surfaces, way too many surfaces.
I'm sure. Yeah.
So that was a big one. When we finished here, we laughed the whole time and we'd count down going, but we did get our Mastercam file over 7 gig. So our Mastercam file was like 7.2 gig when we were done.
Wow.
And that's with all the stock models removed because those were really starting to hurt us. So that's just, there's so many operations in there. The NC code that we ended up putting in ended up being like 1.8 or 1.9 gig of text file only. That's literally the .h files I dragged into the control. Almost 2 gig of text for that thing.
So what was the runtime on that thing?
60 spindle hours. Whew. And we were making 2 of them at once, obviously using part number 1, proved some stuff out. There was a few paths that, we changed, obviously, whatever, all kinds of things happened. And then the second one was our duplicate. Hey, this is a good one because we had a pretty short lead time with this being a big IMTS year and whatnot. Pretty short lead time to actually be able to get this thing done and completed. Back to Connecticut for the CNC software team there to actually take this and make videos and get pictures and do all that. So there was a lot of late nights between me and the Mastercam team, the OSG team. There were a lot of guys who put some time in to make sure that this happened, get this done on time. But yeah, I'd say the other big difficult on the gingerbread house, because this is something we were very proud of, was getting behind the fence and doing the front yard. So as people start to see more videos and pictures and stuff pop up of this, you have a roof overhang with icicles hanging down. All of our icicles are undercut. They look fantastic. you can cut yourself on them because they do get super thin. We made them, we pushed the limits on some of those, and that's really awesome. And there's going to be a lot of videos of that coming out, even with just how we program that and stuff. But doing the front yard really was the culmination of a lot of different tools, tricks, and experience. Dave outdid himself on that one, because really what we did is started with a 3-axis dynamic tool path using a 6mm ball tool to cut the front yard down behind the fence, behind the candy canes, without hitting the wreaths, without hitting the roof, right? Going through and doing this dynamic path, pushing it down, and right, and started that as just a straight 3-axis, don't worry about crashing. Give us the basic tool path. We get our basic tool path. Now I can do a 3 to 5-axis convert, and all of a sudden now I can do tilt to avoids, and I can say, hey, watch out for the roof over here, watch out for this wreath, please don't hit these candy canes or the fence here. And all of a sudden you get some of the footage where we're really, really dancing around on the inside there. That one got our favorite 10-second video clip ever, because the thing spins like 3 times around, and with the C42 lights in there, you don't know if you're in a movie theater or a spaceship or what you're doing, but that thing's just ripping round and around, and it was, that was some of the fun parts we got to see, is some of those tool paths. But the hardest part was probably in front of the fence there. That was difficult. Some of the undercutting of the icicles and finishing the front wall was difficult as well, because as you try to blend to get underneath the icicles of the front wall, you actually have the roof of the front entrance sitting there. So you don't have all the flexibility you normally would. So that was difficult. I know Dave's number one difficulty was the fact that I told him we were going to be on a C22 in the morning he came in to run this, and we had everything prepped and ready to go. I said, sorry, we need to switch to the C42.
Oh.
So we go from a very small trunnion to a machine that's set up with an HS Flex and a pallet machine. So I have the large trunnion on there and a pallet on top of that. So we had at one point, and for most of it, Dave and I had 3 computers running at once, all doing posting and simulation and programming, just cranking away. You put 3 computers together, we probably could have started the table on fire with as much heat that was being ejected out of the back of our laptops. I mean, it was insane. But yeah, that was the struggle, is, and it happens. Hey, I'm in a showroom. These aren't my machines. They're not our machines, really, and if customer needs something, so we just adjust and go. And that's what we did. We laugh about it now. Everything worked out. We didn't have, it actually helped us in some situations too, which was nice. But yeah, that was a struggle as well. It was last second change, because I was out in Germany at the time while they were doing all the prep work. Mastercam sent the raw material to their office in Connecticut there. They did the prep work on it for us and then shipped it to my facility. So the first day I'm back from Germany, I walk into work. I have skids of tools, skids of material, fixturing. We had fixturing for both machines already, so we kind of knew something might happen, so I was prepared for that. But everything waiting to go, and Dave's driving up, and I said, Merry Christmas, we're moving to the 42.
Oh, geez.
He didn't respond so fast.
Well, the next question we had from 2 different people. iMetalWorks and Chief Bub both were asking about your most challenging deployment or challenging project you've ever had to do.
Okay, so on this one, I'm going to have to say it was an automotive part I was working on. I'm getting into the rear diffs for some larger trucks. This was an automated cell. We had 3 lathes and a VMC in this cell, and one of the larger FANUC robots. And the hardest part was actually being on the same page as quality. Being an automotive part, there was PPAPs like you wouldn't believe. We did multiple cells on this, and we did families of parts. So this was not one part number. And the quality team lead at the time and I had a very wide spectrum on what these parts looked like as I did my bench checks versus what he's telling me. Anytime they'd come out and throw a report at me, or hand me a report, I guess, say, hey, this is out. I go back to rudimentary stuff. Guys, I really question this. I can make the change. I don't think this is it, and so there was a lot of back and forth with that, make changes, run it back through Kyle. I don't know what happened, but this is way out now. Yeah, it's because that wasn't the problem in the first place, and the point where we're sitting in quality and everybody's doing manual checks on their own, and then we basically switch tables, everyone, go check the next guys, and just everybody trying to get on the same page. It was very difficult. In the end, and this is just how the project went. It ended up that there was something in the CMM program that was not correct on the way he was referencing plane, or they, whatever, on the way they were referencing planes.
Oh
We
no.
did get Mitutoyo involved and stuff, and they helped out. And it was not an easy situation. It was something that trips people up at times, and it's just one of those things that, the parts we were making, the call outs we were trying to abide by, and everything else. It was something that took weeks and weeks to get through. We scrapped multiple PPAP runoffs. We had skids of parts that, were no ships and stuff, and just red flagged. And yeah, and you'd run every bench check, and you're telling me this is wrong, and I run the bench check, and gauge blocks and pins, man, it's hard for them to. I know they're not perfect, but man, they're not off is what the CMM's saying, and
Right.
you
Oh
go
yeah.
through all that, and it took a lot of time to get down to, hey, we finally figured out what's going on. We got this corrected and stuff, because, you're doing a robot load. So we're using robot vision to first put this part in there. Then we're using robot vision to put it onto the second operation, because we need to have a keyed fixture, a keyed part on there for the fixture. So the robot needs to see where that is, so it aligns the part actually correctly. And, two cells doing this, and we're trying to run 20 parts an hour, and yeah. And all the PPAP numbers, and it was a struggle. That one, that was, yeah, that definitely one is not going to leave me anytime soon. But it's kind of one of those things. It's always going to be something. When I used to go in and do training, my biggest problem was the IT at most companies when they said I want to network my machine. It's a FANUC, guys. I'm sorry. This is 2 pages of information. 3 cells. The rest is on your end. And you'd sit there arguing for days over it. Oh, sorry, it was our end. Yeah, I know it was. And I have 3 cells I can fill in here. And it was just one of those things where, when you're on those projects, it normally one of the things that goes, if it's not set up and taken care of from the start, of making sure those 2 groups are on the same page. Now it's hard, because when I was, back at Paper, I worked with quality a lot, but I didn't know how to run our Zeiss. I didn't understand the Calypso software. I could tell him exactly what I wanted, how I was programming, the way I'm going to measure this by hand, and what I interpret the print as, right? And we can have that discussion and go forward and get down to something that's going to give us agreeable results. But at times that's not always an option. And there's times they said, yeah, we have the program. This is the way it is. This is what we've been running, and that's what you use. And
Oof.
yeah,
That's tough. Yeah. I
So,
programmed the CMM at my last job, and I kind of had an unofficial rule that, like, if I found something to be wrong on a first runoff, I had to verify it a few different ways, because I wasn't going to go back to the machinist and be like, well, the CMM says it's bad. Try again, Bavaria CNC asked, how much fun is it to service a C12? It looks like there's no space left for tools or fingers.
So the one thing I've learned about the 12 and the 22, I've installed the 22 a few times. I did just get to see a C12 finally in the factory. But one thing I've learned off of my service guys is you don't mess around. You just pull that panel. If you're going to think about it, just pull the panel off. If you're not going to squeeze in there, you're not going to be able to come down from the top. Just grab your ladder, get your wrench, go pull that panel, and then you have full access to the machine. So typically on those smaller machines, you can see those panels are coming off right away. Some of the bigger ones, we have room, we have stepping points, we have all kinds of stuff we can get into it. We can do a lot more things, get around inside the sheet metal a lot better. On those machines, the screws come off, the panel comes off, and then we have clear access to what we need. And they do a good job. They come off really nice. So
Makes sense. Definitely. 5-axis evangelist, Cullen, your coworker, says, what do you think are important things people should know when considering 5-axis, and where is the best camping and fishing in Wisconsin?
All right. So considering the 5-axis, the work you have today isn't going to be the work you're going to have tomorrow. Some of the best demos I've done for guys on a 5-axis machine in any of my lives has been that I can take a very simple part that a guy is currently moving through 3 vices or 3 operations, and I can put it into 1 vice, and I can do the top, the right, and the left sides of the part. So, there's a lot of guys getting into different automation builds in my area here, because we have a lot of different automation groups. So they're making a lot of things for automation. They're making a lot of things for the robots. Some of those parts just have that second, third face you need to get to. So being able to drop those into a machine, you can do a lot more with a 5-axis than you think. Not everything is going to be as fantastic as some of the videos we put out where you're doing full 5-axis. Most of 5-axis is not full 5-axis, right? But it's the degrees of freedom I have of being able to move this part, rotate this part. I could get a better quality part out much quicker than having to bounce between 2-3 vices, right? So if I can hold it once and be done, I can do that. Some of the things to look for and be aware of besides, just understanding that portion of it. There's a lot of different builders out there. There's a lot of different makes out there. There's a lot of different fits for them out there. We have a box that we fit in. We fit into that box very well. I would say nobody beats us in that box. Outside of that box, we don't do so well, right? And that's the way it goes. So there may be some guys that have a lot of different options. Just because they have a lot of different options doesn't mean they do it well, right? We've heard some of these in conversations in past, and it is something. And I've heard our sales team say a lot. All of us are experts on the machines we sell. I have been in positions where I was not an expert every time, but because you touched that machine, you are now the resident expert, right? Because you actually saw it and touched it, and you were the first person to do that. Here, that's not the case. Any one of our guys can walk up to any one of our machines, and we can do whatever we want to it, because they are basically all the same. They are basically just scaled models of each other. But there is a reason that, our AG, the factory, went this route 20, 30 years ago, because it is a superior model for what we wanted to do. This is where we wanted to shine, and they've been making it better and better every time. So, pay attention to what you're looking for. Obviously, you get something that's big and crazy, it's not going to fit the bill for everything you're doing. You got to be careful when you get in. You're not going to be able to make the world's smallest parts on, well, I got the bigger, like a VMC, just get me the bigger table, I got more room. Well, that's not the case on a 5-axis. I'll say, so just get me the bigger table. I just knocked out 40% of my work because I can't get down to that size, right? So there's considerations to be made there. And obviously trust your support. That's a big thing. Do you have a team that really truly understands the product that they're selling and working with? How can they support you the best? One thing I really, really enjoyed when I came here is we have a hotline. We have a service hotline and an apps hotline. So applications at hermleusa.net, service at hermleusa.net. Call or email either one of those. There's numbers associated as well. Either one of those, and we take care of you. So we're going to do everything we can up front to make sure that we can get your problem resolved over the phone, email. If we got a VNC in, whatever the case may be, we'll do as much as we can there. If we need to escalate it, whether it's service or apps, well, then we start to escalate and we start going down that road. But we have a lot of guys calling in and say, hey, I have this part. I'm trying to probe this. I'm having problems. This isn't coming out right. Just had another one today. Guy comes in. Hey, I'm kind of looking at this part. I think I want to do it this way. What are your guys' thoughts? And, small, simple things, but that's keeping our customer connected to us. And, we're able to do this. It was something that I quick threw a program on, and then I can run out to the showroom floor quick and run this path really fast. And I can send the guy a video. All right, here's what it kind of looks like, right? So being able to have that and having a team that truly understands their product, it is really going to get you the farthest. So.
And what have you learned about like work holding and tool holding when it comes to 5-axis? Because I think I was talking with Matthias at IMTS, and we were both saying that like that seems to be kind of a underlooked kind of portion of jumping into 5-axis. That like if you buy a Hermle, but then you throw like a Kurt 3-axis vise on there, you're not really getting the full use out of your machine.
So yeah, and that kind of the parts you're running are all kind of going to lead towards that. Though I've done a couple demos where I've thrown a Kurt vise on a 5-axis table and thrown a simple, block in there. And that's, like I said, couple holes up front, couple holes right, left side, no problem there. Typically that's not going to be your work that you have coming through there. So you do want to start looking at some different vices in there, things that get you up a little higher off the table. Typically, I'm going to want to probe on certain surfaces. That's the one really big advantage of us is when I get into a second operation or even a first operation, it doesn't matter. I can tip this table however I want to go probe the bottom surface of the part, and it's automatically going to update that Z value for me, even though I did maybe a X measurement or Y measurement, right? Now that translates back through for me, and that's set up. So with a Kurt vise, I may not always have that because I'm only, a few millimeters or whatever off the table that I can't now get my spindle head and my probe down in there. So you do have a little bit of that to look into. I know some people have, balked or been concerned with, we got all CATS tool holders in here. I don't want to have to buy HSK. Most of them are the same price, if not usually a little bit cheaper because there's less metal in them, right? You got the big old taper on the side. It's just volume. So I've had a lot of shops that actually kind of turned around and said, oh, hang on, that wasn't actually that bad. It's the same I would have spent tooling up a CAT spindle. So, that objection is gone, but yeah, work holding and tooling is definitely something to be taking a look at. And that's where now too, programming wise, instead of, if you're doing a 3-axis, you may just program in and simulate only the tool, never a holder. You use whatever default holder the CAM software throws in there. That's out the window. I absolutely don't do that. One of the things I started doing a lot earlier on too, in the past 5-6 years, is building a lot more libraries. The way when I'm doing turnkeys, that way I have all this done, and it just looks good as you're passing presentations along. But now it really pays off because we need this information. I really need to see where my spindle head's going to be in the Z height. I need to see where that offset is. I need to see how fat that holder is compared to the shoulder I'm coming up against. So, and it's something that, we at Hermle, we have a very large holder database set up right now for us. We got a few of us guys using Mastercam. We use a lot of different softwares, but us Mastercam guys now have been building a really nice library for ourselves. So it's click and grab and go, and we're able to keep moving. But that gives us the most realistic representation of what we're doing. And it really takes the oh shit moments and the scares out of what's going on inside of the machine. Pretty much every move I see in the machine, I should have seen already on my computer screen. So as long as I'm seeing something that looks similar, I'm normally a pretty happy camper at that point.
Totally. Yeah, I thought the replacement table that you guys had on the C250 at IMTS was super cool. The Lang substitution for the table. I was like, oh man, for clearances, that must be amazing.
Yeah, that one worked out very nice for that demo. I like the way that got integrated. Our systems table is what that is bolted to. So it's a 320 millimeter systems table. And it's set up to do exactly that. The gun side machine we have in our showroom as well. I couple bolts, I can pull one table off. I can drop the T-slot table on. I could pull that off. I could drop the Lang fixture on. I could pull that off. I could just interchange all day long. So that keeps us very flexible.
And then what about the end of his question? Where's the best camping and fishing?
Well, as a true fisherman, I will just laugh at him and say absolutely not. But as a camper, I will share some spots. No, there's a lot of good spots for fishing and camping in Wisconsin. We go all over. I have my parents live about an hour north of Green Bay, so we end up in the UP. The Menominee River is up there. It separates Wisconsin from the UP. That's some of my favorite fishing. We do open water fishing and also ice fishing on that, actually. But we do a lot of the state parks around here as well. The state parks are a lot of fun. They're well maintained, and the family always enjoys it. And they're normally in areas too where you're going to be able to go and expand and go check out some really nice small towns and stuff like that too. So
awesome. Well, that brings us on to shop news and new things, which is what's new in your world. What's new for Hermle? What's new for you? Any demos past the gingerbread house that are coming up? What's going on?
Sure. So new, I guess one thing I learned while I was in Germany is that as of this year now, Hermle machines being sold with automation are now more than 50% of what we sell. So over half of all the machines leaving the factory are going to have some sort of automation on them, whether it's a robot or a pallet changer or a big RS system on there. Over 50% are earmarked for automation. So that's really big. That's huge. There's obviously automation, it is where we're going. It's been that trend now for a few years. Everybody's asking a lot more questions. Everybody's doing a lot more with it. So to have us having over 50% of our machines, for me, that's fantastic because this is a factory integrated solution. These things, that was the second half of our training in Germany, was our automation training. So learning the Hawk system for pallet changers, learning the Hawk system for our RS05 robots, and then the Solflex or the Hawks for the Solflex, or the Solflex system for the 2-machine robots, which is our big ones we had, the C32. So Solflex is when you run 2 machines off of one robot, and then we still use Hawks if we only run 1 machine off of one robot. So we went through 4 different software iterations, all of which AG has on their floor that we were able to go do hands-on experience with. So currently I'm working on a project with a customer here where I'm going to be getting into a U-axis head. So I'm actually going to have a tool changeable U-axis head from Comet that comes into the spindle. And then there's a digital interface that touches once it gets spinned in. So now I can control that boring bar diameter. And I'm able to make Z and U moves, and I can do conical tapers now and stuff.
How cool.
There's some parts we're getting into with that. So yeah, that's going to be exciting. We're also gearing up for SHOT Show right now. So the pistol slide demo that was at IMTS, I'm having that back on the machine right now. I'm kicking out some more slides for that. Those will be at the SHOT Show then, a couple handouts here and there. But yeah, so we're gearing up for that one right now as well.
That was a super cool demo. Like seeing how you guys stack all the stock too and stuff. Like it's such a compact way to make so much product.
Yeah. I really, really like that solution. It's nice because, depending on how your orders go up and down and stuff, you could just redeploy one machine for a different part instead of having 10 machines logged to one robot or whatever that, a cell locked up. We're just individual cells that are very flexible. And if you want to run a different part, run a different part. No problem. Right? I don't have to call in everybody and say, you got 2 weeks to get this done. Let's go. And no problem. We just systems table, swap out the fixture. We can swap out the matrix, call in our new programs. We'll be up and running.
That's killer. Well, that brings me to the last question I ask every guest every week, which is, what did you research this week? And it doesn't have to be machining related. It's just what's been popping up in your browser that's been keeping you interested.
It's pretty much always machining related. So this week it was batch files. I've done some computer programming. I've written some tool library programs and stuff, for shop inventory stuff. I play. This week it was very simple though. So we run a lot of sub programs. Typically the way we break our programs out, we run a lot of sub programs. Those are typically numbered like 0010 underscore roughing 0020, right? And it's just 10, 20, 30, 40, whatever, and all the way down. And the hard part is making a main program that actually encapsulates all those file names into one. So I ended up writing a batch file. You put this batch file into your folder that has all of your subprograms, double click it, it runs through, it reads the file name list in the directory, it goes through and it builds me a main program with some additional text built in. So I'm going in, I'm pulling some strings, I'm changing some strings, but in the end I create my main program that's a .h that you can stick right into the machine and hit go. And in this instance for the gingerbread house, it will call all 44 subprograms without me having to go to the control and manually build this one file at a time to build this main program to call these programs. So I got into that, and then I also started building a protocol to track main program time, subprogram time, tool breakage detection, just tool life, just kind of a little everything as I started playing with really what the hide and high control can do. With being able to create and read tables, and I'm creating a text file that's a report. And, at the bottom of it, I had not that weirdly enough, but I had a gingerbread house in ASCII art, right? So a lot of asterisks in this. That, like the last part of my protocol is it kicking out a gingerbread house that says Merry Christmas. But it was just me learning, okay, what does it do with this code? How do I get this to come over? And, I had to call into different areas, and, maybe Easter, I'll change it over to something else, so as I run my protocol, it changes that graphic in there. But now I have something I can go back to and take a look at real machine time on a protocol that I built that gives me my start, my stop time, the actual minutes and seconds each of these ran, and tracks all these different events. So it's something that I've seen before and wanted to play with a little bit. And that's what I've been really geeking out into lately.
That's super cool. I knew that you could create tables and stuff like that, but I didn't realize it was that variable that you can kind of do whatever you want.
Yeah, so the protocol just ends up being a .txt file. And with that, it's just how I build my spacing and stuff, obviously, for that. But yeah, I have it set up that it gives you, all your timestamps right out of the system time. And we're reaching into machine parameters and grabbing tool numbers and all the good information you want, just building a report. So when the job's done, I can walk up and say, oh, yeah, there it is. Cool. And then when the next one runs, it just adds it to the bottom. So for me, I'll have a running protocol and a running report of what I've done. So I'm sure it'll evolve over time, but it's just dipping my foot right now.
Yeah, that's awesome. That is super cool. Well, Kyle, thank you so much for taking the time to come on the show. If there's anybody has any more questions about Hermle or anything, where can they reach out? What's the best way to do that?
So I'd say if you're going to have any questions about Hermle, let's just go ahead and reach out to applications@hermleusa.net. Anybody, please go ahead. We have teams of people that are watching that, and we have customers and potential customers that send stuff into that group, asking questions, saying, hey, your sales guy was just here. I got questions on this. Please feel free to reach out to applications. If we need to branch you out to anybody else, we will handle it at that point. But yeah, applications@hermleusa.net.
Awesome. Well, again, thank you so much for taking the time. I really appreciate it.
Thanks for having me on.
And thanks to all the Patreon members, new ones, High Performance and Zach. Thank you guys. You make this show possible. And thanks everyone for listening. I'll be back next week.